a wave? Well, a wave can be described as a disturbance that travels through a medium from one location to another location. There are three types of waves: longitudinal waves, transverse waves, and surface waves.
A transverse wave is when the direction of wave motion is perpendicular to the direction of the substance making up the wave. As you can see in the diagram, the highest point of the wave is called the crest and the lowest point is called the trough. And the distance from a crest or a trough to the midline of the wave is called the amplitude.
This diagram represents longitudinal waves. A longitudinal wave is when the direction of the wave motion is parallel to the direction of the substance making up that wave. When the particles are closer together, it's called compression, and when they're spaced apart, it's called rarefaction.
The last wave is called a surface wave, and the particles move in a circular motion.
Waves are everywhere in our daily lives. Some common forms of interactions include refraction, reflection, diffraction, and interference.
Refraction is when a wave bends because it travels from one medium to another and changes its speed. For example, when we have a glass of water with a spoon inside, we notice that the spoon changes its shape. This is because light bends from one medium to another, from air to water, so the spoon changes its shape.
So reflection is when a wave hits something or a surface and bounces off. For example, here, the light hits the city and it reflects on Salma's face. Diffraction is when a wave bends around an obstacle or through an opening. For example, the flashlight passes through the opening of the CD and it hits the computer. That's why you can see the light.
It's not blocking. There are two types of interference: constructive interference, which is when a wave meets or hits another wave and forms another wave with a larger amplitude. Destructive interference is when two waves meet and result with a wave with a lower amplitude.
To begin with, we will talk about sound waves and sound barriers. Sound barriers are what stop sound waves from progressing, thus lowering or eliminating noise. Two examples of common sound barriers are noise-canceling headphones and soundproof glass. Will someone shut that baby up? Can you please pass me the headphones? So much better.
Salma, do you want to try my food? Salma?
Hey guys! What's up? Hey Salma! Salma, I'm here.
She's talking to. What?
Hi.
Hey, what's up, guys?
How come you couldn't hear me?
Oh, it's because I just got these new Dre Beats and they work so good.
Yeah, but when I have my headphones on, I can still hear the people around.
Well, I don't know, but these headphones are really good. I don't know why.
Oh. Why is that, Salma? I'm sure there's a reason.
We wonder why.
The reason why Salma couldn't hear us is that she was using noise-canceling headphones. A headphone is a pair of loudspeakers that can be placed over the head or in ears. It transmits sound waves through the ears to produce music. The amplitude of the sound waves determines the intensity or the loudness of the sound. Many types of surrounding sounds can impede or even block the sound waves coming through the headphones. Luckily, noise-canceling headphones can make music more enjoyable and clear. There are two types of noise-canceling headphones, which are passive and active types. Passive noise reduction can be provided by most headphones because the headphones materials themselves block some high-frequent sound waves. That means they are packed with layers of high-density foam or other sound-absorbing material, which makes them heavier than normal headphones. Passive noise-canceling headphones prevent sound waves from reaching the listener's ears. Another type of voice-canceling headphones is active noise-canceling headphones. They have structures that create a barrier that blocks high-frequency sound waves. They reduce the noise also by erasing the lower frequency sound waves. Noise-canceling headphones achieve this by creating their own sound waves that imitate the incoming noise. The sound waves created by headphone speakers and the noise created by external source share equal amplitudes and frequencies, but their compressions and rarefactions are arranged so that the compressions of one wave line up with the rarefactions of the other wave, and vice versa. The two waves cancel each other, forming a smaller amplitude. This phenomenon is called destructive interference, which enables the listeners to focus on the sounds he or she wants to hear. This diagram shows what I was talking about. The headphone speakers create waves, and the external sound combines with the waves that the headphones does, and when they combine together, destructive interference happens because the amplitudes of both waves are equal, and the result is silence. When the two waves have equal amplitudes, they cancel each other.
So now we're gonna talk about soundproof windows. What? What? I can't hear you. I can't hear you. I can't hear you. I can't hear you. So the reason why I can't hear them is because soundproof glass is made of laminated glass and a PVB layer of plastic, and it stops the vibration. For those of you who don't know what PVB is, it's a type of plastic. There's an air space between the normal glass and the soundproof glass, so the frame is completely isolated from the vibration. So to sum up, soundproof glass is actually two panes of glass that have a vacuum in between them. Since sound is a wave, it needs a medium to travel through. With no air, sound can't be transmitted, so the vacuum between the panes of glass creates an area with no air that prevents sound from being transmitted, and it makes it completely soundproof. The black rubber that is placed around the glass prevents the sound waves from diffracting. That's the black rubber that's preventing diffraction.
The end. Will someone shut that baby up?
Someone stop looking at the camera.
No, give me the headphones right now. That's... No!
Salma? Hey you guys! What's up?
Someone, Jesse's talking to you.
Salma! Salma! You said you'd give me your headphones.
My name is Barnabas Collins. 2 centuries ago, I made Collinwood my home, my love, until a jealous witch cursed me, condemning me to the shadows for all
Where are your
time.
headphones? I don't want to watch this. What the hell?
What the hell is this?
He's coming. He's coming.
So the reason why I can't hear them is because soundproof have a vacuum in between them. Since sound is a wave, it needs a medium